our students left our campus for spring break. And the last thing that they or any one of us at NC State would have imagined is that shortly after that, we were going to be telling them, don't come back. And this is something, of course, that was a result of the situation that we're all dealing with, this global COVID-19 pandemic, which essentially forced us to shut down all of our in-person activity, all of our classes, all of our meetings, all of our events, and pivot very abruptly and very quickly to total online instruction and the world of Zoom and video conferencing that we're all living with and working through as we speak. I'm very proud to be the Dean of Engineering at NC State, but I don't think I've ever been prouder than at this moment. The tremendous effort that our college faculty and staff and our leadership have made to not only carry out this pivot, but to do it in such a way that's provided the educational continuity to our students that they so much deserve is something to be very, very proud of. We sort of likened it to the challenges of trying to move something very heavy over a short runway, if you will. But the bottom line is that we're now up above a certain level of clouds and moving forward, understanding that our challenge is now to stay the course. So this provided all of our students, practically all of our students, with a way to continue their academic programs. And the net result of this is that we were able to complete the spring semester and graduate all of our graduating seniors. The university in general graduated over 6,000 students in spring. Now, none of this was easy. And as you're going to hear today from our panel, they will share with you some of the challenges that they had to address either as administrators, faculty, or students in this transformation. And you're also going to hear from them how our engineering community has been able to respond in many ways to support the effort of healthcare and other first-line providers who are really at the front of the challenges associated with this. But where are we now? Well, the bottom line again is that we completed our semester. Over 6,000 students graduated from NC State. They were not able to have an in-person spring commencement from the university, but many of our departments and units did provide them with a moment for them to cherish with virtual graduation or virtual celebration events that were very, very special. All of our summer activities, this is courses, camps, everything else, have been canceled in person. But interestingly enough, we now have a number of virtual summer camps going forward, K through 12, all the way through high school. There's a lot of creativity and ingenuity that becomes unleashed in a process like this. And we're steadily bringing, very slowly now, very slowly, starting to bring back our research activities that are really sort of conditioned to the phase 2 guidelines of the state and the university's interpretation of that. Research is a huge part of what we do in the college. We had to close that down, as you might imagine, also abruptly. But that is starting to come back very slow and very guardedly. We're hoping, all of us at NC State, anticipating with hope some measure of in-person education and presence in the fall. But I think we all recognize and understand that this will not be the kind of presence that we were used to seeing last fall or the years before. We're not quite sure exactly how that's going to play out. We've had our faculty preparing for adjusting between inline and in-person. The academic calendar at NC State just a day or two ago was announced to be a bit different. We're going to start the semester earlier on August the 10th. We will have fall breaks, and the intent is to complete everything by Thanksgiving so that people would not have to come back and be able to stay away for a period of time. But all of this, again, is going to play out as the time goes by. There's a lot to happen in May and in June and July, and the dominant consideration that we have over all of this is the safety and health of our students and our faculty and our staff. But in this, your support is very critical. I'll address more of this at the end of this interaction. But at this moment, thank you again for being on this call, for all of your support. And Pam, let me just turn this back to you so you and the panel can proceed with the event. Thank you guys very much.
Thank you, Dean Louis. So for the format, each panelist will speak for a few minutes. Please type in any questions you may have for the panelists in the Q&A, and I will address them to the panelists at the end. If we run out of time, the answers to the questions will be sent to you via email along with a recording of the session. So let's begin with Dr. Landon Grace. Dr. Grace is an assistant professor in mechanical and aerospace engineering with a focus on polymer and polymer composites, including those used in medical applications and devices. He and his team of graduate and undergraduate students have been designing and manufacturing COVID-related devices since March 20th. He will speak about various COVID-related initiatives in MAE and across the college, including fabricating components for respirators, ventilators, intubation shields, and other critical items. And what is really touching for me is how he got involved to begin with. Dr. Grace.
Thanks, Pam. So I'm going to start with one of the questions I get most often these days, which is, how did you get involved in all of these things? At first, it's no surprise that everyone turned to NC State engineering as they started to encounter these seemingly unsolvable problems as this started, because that's what we do here. We solve unsolvable problems. The thing that people wonder about is how I got involved in everything from face shields to ventilators to innovation shields. One of the people I work with at UNC Health very closely said he thought I got too close to the event horizon and got pulled in, and that's fairly accurate. And there's really only one person to blame for that, and that's my wife. She's actually a physician, and back in mid-March, an ICU doctor at Rex posted a question on a local Facebook physician group asking if anyone had any contacts at NC State to help with medical device shortages. So my wife was more than happy to volunteer my name, and I was on the phone getting my first problem definition about an hour later. We were able to fabricate a prototype within about 72 hours. And word started spreading to health systems across the triangle, then the state, and then the country. So it really is her fault, but I wouldn't change a thing. And the last couple of months have been, honestly, some of the most rewarding in my career. So I recruited a group of students from within the college, and we started defining the problems, the constraints, and the priorities and the timelines back in mid-March. And it really was a Herculean effort there at the beginning, and all the credit goes to my team of students. They really didn't shy away from this onslaught of difficult problems and shifting constraints in the early days of this. They tackled it head on. They learned an incredible amount, things that can't be taught in a classroom, for example, like how do you adapt when the factory in Malaysia that's been providing rubber for one of these devices all of a sudden stops shipping. And you have thousands of healthcare workers depending on you to still have 2,000 of these by the end of the week. They did an amazing job, and even more impressed now with the quality and the ingenuity of our students than I was when I came here from the University of Miami about 4 years ago. We have an incredible culture in the college that's manifested in our motto, and we've had to think and do in rapid succession over the last couple of months. And so I'll briefly go over some of the items we have designed and manufactured. I've got some pictures here to show you. The first one here in the upper left is a disposable lens that attaches to a helmet to generate positive pressure around the user's face. So this is something that's a little bit more substantial than an N95. So it has to interface with a variety of helmet types, has to seal securely under the chin. We started out making about 80 of these per day on a very manual process. As of today, our record in a single day is 1,650. And all that comes from automation, process optimization, and a whole lot of ingenuity from our students. One of the things I've encouraged the team to do is to continue to innovate and improve the process and the product. So we're really not in the business of running factories here, and I didn't want them to settle into the routine of an assembly line. So they've continued to innovate, and it's been amazing to watch. One of the most difficult design constraints we've faced has been the supply chain. So we had to figure out what was available, how quickly it could get here, and then adapt our design and our processes to suit it. So we couldn't wait a week to receive heating elements or cartridge heaters for the welding process, for example, but guess what? Target sells a very nice electric griddle for $25 that has a perfect heating element inside. And those are the kinds of adaptations we had to make. So as of today, we've made somewhere between 15 and 16,000 of these. And since sent shipments to California, to New York, and to Illinois, and the vast majority have stayed in North Carolina, well over 10,000 of these. And the things that kept me going, kept the students going early on when it was 7 days a week, sometimes 10, 12-hour days, was messages like these you see up here in the upper left. We got endless thank yous from the medical community as these started being used in the field, and they continue to come in. I actually got a letter today from a hospital in Greensboro. Another item we made was this intubation shield. In the lower left, we've made 73 of these so far, some modified for various high-risk procedures, and have sent those to hospitals all over the state as far west as Asheville. This has some unique features like this curved top shield and a disposable front curtain that you can pull down if somebody has to go around to the front of the patient and do chest compressions or something like that, for example. So that's a design we're very proud of. It's been used several times. We've also produced thousands of more basic face shields. Dr. Ola Harrison and Dr. Tim Horn have spearheaded that effort. My group also organized a network of community-based 3D printers to ramp this up really quickly. And they responded immediately by printing well over 1,000 visors for face shields that we inspect, assemble, and ship out mostly to smaller clinics around the state. And I know that Ola's group printed several thousand in-house here at NC State and provided those to some major health systems. Dr. Dayton will talk more about the ventilator prototype, but my group was also involved in that. One of the main things that we contributed was designing and building a PEEP valve based on off-the-shelf components that you could get from a hardware store. And we've made that open source. And then we've also done countless miscellaneous repairs and things like that. So we've designed and printed dozens of small parts and components that have been critical to keeping a lot of this equipment operational. Most of it isn't terribly complex, but if it breaks, that equipment can't be used and that people can't be protected. And believe it or not, requests continue to come in for help making PPE and other items. I actually got a request for another 1,000 components we prototyped earlier this week and sent to a hospital for a first article test, and they liked them and want 1,000 more. So we've made about 16,000 of those contained air purifying respirator. I don't know if I mentioned what that stands for before, those CAPR devices. And there's a need for at least 24,000 more just in the state of North Carolina. So there'll be 40,000 of those at least before we're out of this. So we continue to respond, and the notes of thanks from the community continue to come in, and that's what keeps us going. And my students and I are always looking forward to the next problem to solve, which is what we do as engineers. This has been very representative of an engineer's role in society, is solving these problems. And there's literally no better place to do that than here at NC State. I'll pass that back to you, Pam.
Great. Well, thank you so much, Dr. Grace, for your tremendous contributions in keeping our healthcare professionals safe at this time. Next, we'll go on to Dr. Paul Dayton. Dr. Dayton is the William R. Keenan Jr., a distinguished professor of biomedical engineering and the interim chair of the UNC-NC State Joint Department of Biomedical Engineering. The Joint Department is a unique partnership which brings engineers and scientists across the two campuses together to solve problems in medicine. Dr. Dayton directs a research group which studies ultrasound for medical imaging, targeted therapeutics, and industrial applications. And he has co-founded 2 companies which are commercializing now biomedical ultrasonic technologies. Dr. Dayton.
Thanks, Pam. So, yeah, I want to emphasize really our unique partnership with biomedical engineering. It's really one of the first of its kind, that it's a true joint partnership across NC State and UNC Chapel Hill. And it's really what enables us to fulfill our mission of uniting engineering and medicine and improve lives. And COVID-19, the pandemic, has been a real test to rev up our engine. So on Tuesday, March 17th, the chancellor confirmed that there would be no further in-classes at NC State and that all employees should transition to remote work. And this meant biomedical engineering would need to transition 600 students to online education within 2 weeks and nearly completely shut down our $21 million research enterprise within a few days. In the midst of the anxiety and planning process that this required, I received a phone call from Kristen Page, who is the executive dean of the UNC School of Medicine. And she informed me that UNC healthcare system was facing a massive crisis of personal protective equipment and medical equipment, and they needed help. Later that day, I was on the phone with Carol Lewis, the vice president of UNC Health Enterprises. And that Thursday, I was in a meeting with the UNC Hospital Supply Chain Logistics, being told that there were less than 25 days worth of stock in N95 and surgical masks on hand, with no resupply in sight. With the rapid spread of a highly contagious airborne respiratory disease, the physicians were terrified. They were looking for any and all possible solutions, including engineering and manufacturing our own PPE. I immediately became part of a task force working in several directions, initially focused on masks. These included short-term solutions such as contacting labs across NC State and UNC and rounding up extra masks that might be available from research labs to donate to the hospital. Medium-term solutions such as researching technologies to sanitize and reuse existing masks, and longer-term solutions such as fabricating our own masks in-house. The rate at which these tasks were moving forward was almost explosive. We were having Zoom meetings and phone calls from 6 a.m. to midnight, and within a few days, we had a large group of folks working together on many of these tasks. Team members included other BME faculty, staff, and students, physicians from UNC hospitals, medical students, other faculty and students from the College of Engineering. Landon Grace has been a major contributor to this team, as you just heard, as well as UNC Makerspace staff, Ben Portahimi from the Nonwovens Institute, scientists with expertise in airborne pollutants and filtration at the EPA, and legal counsel. Furthermore, we had expanded far beyond just masks, realizing within a few days that the hospital was also facing severe shortages of ventilators, face shields, powered respirators, and other key medical equipment, given the projected needs of the coming pandemic. Governor Cooper's office from Raleigh had reached out to us as well, eager to understand our solutions and with a desire to source material for state emergency management. Never before have I seen such a diverse team come together across the different universities, schools, and colleges in such short notice. Within 1 week, we had prototype mask designs. By the second week, we had a prototype ventilator. By the third week, we had learned that the hospital pediatrics department had completely run out of masks for child patients. They were literally at zero. Devin Hubbard, one of our BME faculty, worked with the team to design a process to make pediatric masks from adult-sized masks. We assembled a group of student volunteers to learn the protocol, and then in socially distanced shifts in the BME design lab, fold and heat seal these masks for children. We had 400 pediatric masks delivered to the hospital within 48 hours and 1,000 within a week. I was literally walking across the street to meet a physician and dropping bags of handmade pediatric masks at the curb like it was some sort of contraband exchange in a spy movie. Over the next few weeks, our directions continued to expand. We made thousands of pediatric masks, eventually turning the process over to a hospital supply chain in Morrisville about 2 weeks ago that continues the process to date. We have a vetted ventilator design, iteratively tested, moved into fabrication with local industry partners, and we've made this technology open source. We have a frame technology which allows a user to greatly improve the filtration performance of poor performing KN95 masks or surgical masks by improving the seal to the face, which is now pending patent and being considered for commercialization. Next slide, please. Furthermore, during this process, we've also pivoted our project-based learning. In senior design, about half of our design teams, which were no longer able to work on campus, chose to pivot to new COVID-19 related projects. The BME design process is intended for this very situation. Challenge identification, testing, design, testing, and eventual commercialization. Our students are trained to bring together engineering and medicine to improve lives. It's just that nobody ever expects it to happen in a 2-week period. Senior design projects included coordinating hand sanitizer production with local distilleries, designing respirator splitters and controls, designing microfluidic COVID-19 virus detection systems, antiviral coatings, and more. Although not all of the projects had the same level of engineering design that would have been ideal if we were able to meet on campus, all of these students had an experience and real-world impacts that they will not soon forget. At this point, the ventilator urgency is wound down somewhat, partially as social distancing has been able to slow our curve somewhat so far. And the supply of chain for surgical masks has recovered a little, but we are still far from being out of the crisis. N95 respirator masks and several other medical supplies, as you heard from Landon, remain in very short supply, and we continue to work on substitute technologies. Several of our faculty are now ramping up towards crucial long-term projects. David Zaroff, who focuses on immunology, is working towards vaccine for the COVID virus. and Bill Polachek is working on rapid antibody testing. Both of these areas, vaccines and testing, will be crucial over the next year as we hope to resume life as we used to know it. Thank you.
Well, thank you so much, Dr. Dayton. What a critical role you and your team have played in our community during this crisis. It's just very invaluable. I'd like to turn now to Dr. Julie Swann. Dr. Swann is the department head and A. Doug Allison Distinguished Professor of the Fitz Department of Industrial and Systems Engineering. She is also an affiliate professor in the Joint Department of Biomedical Engineering at the University of North Carolina at Chapel Hill and NC State. Prior to joining NC State, she was at the Georgia Institute of Technology, where she co-founded and co-directed the Center for Health and Humanitarian Systems, one of the first interdisciplinary research centers on the Georgia Tech campus. In 2009, she was on loan as a science advisor for the H1N1 pandemic response at the Centers for Disease Control and Prevention. Today, Dr. Swann will talk about ongoing activities related to COVID-19 in the department, including developing disease models, quantifying hospital surge capacity, and understanding supply chain disruption. Dr. Swann.
Thank you very much. One thing that I wanted to talk about just a little bit is the impact that COVID-19 and the campus decisions have had on departments, including faculty, staff, students. As Dr. Dayton mentioned, faculty received the word that we would be moving to online classes, and in 2 weeks, almost every single class at NC State was put online. That is an extraordinary change, as you might imagine, and I really want to thank the faculty and staff for making that happen, and the students for persevering, because it was not easy for them either. They were asked to go back to their permanent residences and develop whole new styles for learning in this new framework in order to keep everyone safe during this time. Like other departments, we have continued to plan, and the university as a whole is planning for both summer and fall, and for the eventual movement to our new building, Fitzwillard Hall, over on Centennial Campus. But of course, some of that has been disrupted, and there are lots of changes. Now, throughout everything you've heard today, we talked about disruptions, and in fact, disruptions can lead to innovation, and that's what we are trying to do. The Industrial and Systems Engineering Department has been active in some areas around making equipment, like what you saw from Dr. Grace and Dr. Dayton. So our Center for Additive Manufacturing and Logistics, led by Ola Harrison, has been actively making face shields that can go around a mask to make it fit more tightly to a face, as well as ear savers to make it easier to wear masks for medical personnel. So these have been distributed to a number of different hospitals and doctors' offices, as well as dentist offices as well, who are at risk as things begin to open up. In addition to our faculty, we've had alumni, and I'd like to give a shout out to them as well. Alumni who've been actively participating in supplying personal protective equipment. Specifically Baker Furniture through the work of Mike Jolly and Debbie Beaker, and McCreary Modern through the leadership of Rick Coffey. And both of those organizations turned their operations around and started making masks and distributing them widely. We had a recent seminar where they talked about their experiences, and I told them I think that they are partly responsible for the low transmission that we've had to date in North Carolina, because they have distributed thousands and thousands of masks across the state, especially the western part of North Carolina. Next slide, please. Now, that is on the detailed level, but in fact, industrial and systems engineering does a lot of things at the higher level as well. As was mentioned, we're involved in supply chains and thinking about that. And actually, my personal background is that I've been working on pandemics for more than a decade. I had done work on influenza pandemic in advance of the H1N1 pandemic that arose in 2009, and that's one of the reasons I was on loan to the CDC during that time period. And what what I and others in my field have been doing is that we build disease models that are basically mathematical representations. You can simulate them on a computer. And then we look at different kinds of scenarios, and we often overlay that with logistical or operational level decisions. So in this picture here, I'm showing a typical disease model where someone begins as susceptible to a disease, they may be exposed to it, they become infectious to others, and then at some point, of course, we hope that they recover. That's a very basic SEIR model, but that is often embedded in some of the most robust disease models. The modeling that I've done is based on agent-based models across a network. So you have households of individuals of different ages. Each one of them might be going to schools or workplaces and interacting in a community. And you're simulating all of this to project the disease spread and the impact of things like distancing policies. On the right-hand side, I give an example of some results that are coming out of a recent model that we produced, and this is with my colleague Keskinojek from Georgia Tech and some others from Georgia Tech. And you can see here that in North Carolina, we've had fairly low transmission so far, but we do expect that if distancing does not continue, or that if masks are not worn, that we could see a pretty significant increase in cases. I'll be talking more about disease modeling and what's in the background and how these work and what some of these projections look like next week in a seminar. That's Friday, May 29th. If you go to the ISE website at NC State, you can get more information on how to participate in that if that's of interest to you. And as I mentioned before, we're often doing the disease modeling linked with logistics or operations. So one of my colleagues recently put together a group of researchers studying what the pandemic does to travel demand, both the demand of commuters as well as the demand in the supply chain, especially that last mile, where we certainly, I imagine many of you have had shipments coming to your house in many cases, more so than what you might have had before. And so what is the impact of that on the community, on society, on our roads, those kinds of things. We have a team of faculty, Dr. Osman Azaltan, Maria Mayorga, and Julie Ivy, who are looking at hospital surge operations. So during something quite big like a pandemic, demand for medical services can decrease because of elective surgeries being postponed, and perhaps people are staying at home more or doing more telehealth, as we've seen in this pandemic. But on the other hand, demand can also increase for emergency room visits or hospital cases associated with COVID-19. And so they're looking at that. They're really working with several hospital systems to capture what those changes look like, as well as understanding the decisions that are put in place towards thinking about future decisions. We've got another group of faculty and researchers working on cyber manufacturing, which is another approach that can help our supply chains be more effective at delivering products in critical times, like when there's surge, like we've seen during the pandemic. And cyber manufacturing basically allows you to take algorithms and have different machines talking to each other, and you could produce different components of a final product in different places. They are then brought together and assembled, so it can be an effective use of machines in different places, but also can be effective at dealing with situations like what we've seen with COVID-19. Our faculty have also been active in various things in the media. So we've been quoted in the Raleigh News and Observer, several national papers, and faculty member Julie Ivy recently had an op-ed in her hometown, the paper there, and the Detroit Free Press, and many others as well, really with the goal of trying to make sure that science is being explained well in these articles that you may be reading, and that we're thinking not only about today, but also about moving forward. And throughout all of this, through our teaching and education, through our research, we're really focused on how can we take the positive sides of this major disruption, which has, of course, led to many devastating effects on health and on financial and other types of aspects. But what things can we take away from that and have positive come out of it? And one is the innovations that can come from those disruptions.
Very good. Well, thank you, Dr. Swann. It's so good to know that you and your team are focusing on really the logistics of a pandemic. It's very comforting. Thank you. And our final panelist today is Leah Purcell. Not quite a doctor, not yet. She's a rising senior studying mechanical engineering. On campus, she has spent the last 4 semesters as a MATLAB teaching assistant. She is also the president of Engineers Council, which serves as a bridge between engineering students and faculty. And Leah's going to share a student perspective, including transitioning to online learning. Leah.
Hi, everyone. So real quick, I'd just like to take a second to introduce myself. So I'm a rising senior studying mechanical engineering, and during my time at NC State, I sort of realized that I was interested in space exploration and all of the exciting engineering accomplishments happening in that industry. So I started to tailor my mechanical degree to have an aerospace focus, and after graduation, I hope to get a job in the aerospace and defense industry. So now I'd like to share sort of a student perspective of everything that's happened over the past semester. So my experience with all of this has had a bit of an interesting start, because when it was announced over spring break that classes would be online for the rest of the semester, I was actually on an alternative service break with the university building houses in Peru. So if you can imagine, there's a group of about 16 of us working out in the Peruvian desert, and the coronavirus was really the last thing on anyone's mind. So I think everyone knows how quickly things changed with the coronavirus. I mean, every day, major unexpected news was coming out. So a lot happened in the few days that we were without internet. And when we heard that classes were moving to online for the rest of the semester, it really didn't even seem like it could be real. So of course it was real. And at this point, it's been almost a month since we all took our finals and finished up an entire half of a semester entirely online. So I think we all became Zoom experts and also experts at taking pictures of engineering paper and turning them into PDFs to submit online. So those are definitely 2 concrete skills that I've gained from this experience. But on a more serious note, as scary and as sad as this has been, and as much as we would never want it to happen again, I think that a lot of students, myself included, have grown from this experience in really positive ways. So first of all, I think that we all gained a lot of time management skills really quickly during this time. Many of us found ourselves living with our parents again, which was definitely interesting. And our parents haven't necessarily experienced the strained schedule that college students have, so it was a bit of a shock, I think, on both ends for them to actually experience that with us. And as much as college teaches us that we are adults and we are responsible for setting our own alarm clocks, getting out of bed, and making it to class on time, online classes really just take that to a whole new level. So I want to take a minute to talk, logistically speaking, about how online classes were run. So of course, I can only speak from my personal experience here, since every professor ran their class differently. But there were essentially 2 different lecture styles that could be implemented. So the first style was synchronous learning, which basically means that the class got on a Zoom meeting at the regular class time, and the professor delivered the lecture live to students. The second style was asynchronous learning, which essentially means that the lectures are pre-recorded and students can watch them whenever they'd like. MediaSite was a common platform that professors use for this method, where students see the professor and the slides at the same time, like I have shown in the picture. But there were really a variety of ways that different professors taught the classes asynchronously. And this was actually how most of my classes were run. So I think you can probably guess what the hard part about being able to take all of your classes whenever you want is. So to combat procrastination and give myself a sense of having a normal schedule, and also just keep myself in school mode even while I was at home, I definitely tried my best to watch all of my pre-recorded lectures during the normal class time as if it were just being delivered live. So this also helped each day seem less overwhelming, because it can be pretty daunting when you can just log on to Moodle, which is our classroom management site, and just see every lecture that you need to watch for the rest of the semester for each of your classes. So keeping to my normal schedule as best I could helped me take the semester one day at a time. And all of these skills, time management, organization, self-motivation, we all picked them up quickly and in a very unique environment, but they're definitely skills that students will carry throughout the rest of our education and even into the workforce. So as far as online classes go, I think it was really cool to see how every professor found a way to continue a class online. And I did have one professor who really stood out to me as sort of being the champion of online learning. So my heat transfer professor pre-recorded his lectures so we would watch them on our own time. And then once a week during our class time, he would hold a live Zoom meeting where he would summarize his lectures, go over extra practice problems, and answer questions from students. He was also very available outside of classes and basically told us that we could send him a calendar invite for any open time on his Google Calendar, and we could do a one-on-one Zoom meeting to get personalized help. I would be willing to bet that most students have stories like this, where they had a professor just really go above and beyond to be accommodating during this stressful time. I think that this was a really cool moment in the university's history where students and professors were truly learning right alongside each other, and we were all adapting to our new normal together. And although it's probably a little weird to say, I think that in some cases there was a sense of community on some of these Zoom calls that didn't necessarily always exist in the classroom. From the Student Emergency Fund to the grants available to students affected by the coronavirus, I think that the university did a good job taking care of students while they were away. Something that I personally really benefit from was that students were able to get free textbooks through VitalSource, which is an online textbook platform that a lot of classes use. Textbook costs can add up fast, and since I typically do my homework at Hunt Library, rather than buying textbooks, I would just rent them from the library when I need it. So when I heard that the library was going to be closed, that was kind of my first worry. So it was really relieving to hear that this wasn't something that we were going to have to worry about and we were going to have access to textbooks. Also, the university implemented new grading options, which allowed students to change classes to be pass-fail and still count for graduation requirements. For reference, during a normal semester, students can take classes like gym classes to be pass-fail, but academic classes must be taken for a grade. But this semester, we were allowed to change our academic classes to be pass-fail. This took a lot of pressure off students during this already stressful time. The second half of the semester, school was not the most stressful thing in the lives of many students. Some students may have had a loved one pass away or become sick due to the coronavirus. Some students may have had a parent lose a job to the coronavirus. And some students may have just been experiencing general anxiety about anything from their health to taking classes online. So no matter what the additional stressor was this semester, I think that every student had one, and I'm grateful for the effort put in by the university to continue to take care of students during this time. I think that this was a time where students and university staff together showed what we really mean when we call ourselves the Wolfpack. Thank you.
Wow, thank you so much, Leah. That's very inspirational, and how special to get a glimpse of the challenges and solutions that students faced at this very unique time. So now I think we're going to address some questions and answers. I think a Q&A has come in. And so I'll start by reading them off, and hopefully everyone can hear me. So the first question: were research programs involving living biological test subjects like horticultural, animal, microbial able to be continued during the shutdown? And perhaps that's for you, Dean Louis.
So the amount of effort that continued during the shutdown was very, very limited. There was something we called a phase 0 on campus. And we did, the University Research Office did accept a lot of requests actually to open up at that time. But those that were most critical in terms of being supportive of what was happening with the COVID situation, and cases like the one that are being referred to here tended to be the ones that had the highest priority. So I guess the best answer I can give is that I'm aware that some of these were able to continue, but I can't say that all of them were, but they were very high priority, at least at this moment. Yeah.
Yeah. And any follow-up from any of the other panelists on this one?
Yeah, I don't know if Paul has perspectives he can share on this as well.
Yeah, I would agree with Louis. Most projects that were not directly related to COVID-19 were shut down due to the potential risks that our faculty and staff would have been facing. But there were some exceptions. People that were working on vaccines and so forth that might have used animal models, and those were given permission to continue because they're vital to our fight against the pandemic.
Very good. Thank you. All right. The next is for Dr. Grace. Did you interact with companies to expedite production of your innovations designs? And if so, what are some of the companies that your department worked with?
Yeah, we did. I considered our role really to innovate and then to bridge the gap to make sure that the healthcare systems are provided with the PPE they need. But when you're talking about making 40,000 of something, I think that's more appropriately done by local businesses. And we did work with some small manufacturers to help with some of the production early on. KM Crafting, it's a local furniture maker that has a laser cutter that we used. SAS actually stepped in and helped us out quite a bit. Believe it or not, they have a nice machine shop. Let's see who else. And then the bigger one is a local medical device manufacturer called Polyzen. And we're working with them now on transitioning some of this, the capper lenses specifically to them. And it takes a while actually for them to ramp up, right? So we designed tooling and dies and things like that here in-house and provided that to them. And they're starting just now to produce a few of the parts that we need to assemble these. So it's our goal to once we get the process lined out and there's no more innovation, to kind of pass that off to local businesses. And there's been a lot of interest in that.
Good. Thank you. All right. So a question, have there been considerations of making reusable PPE? And not sure who best, perhaps Paul or Dr. Grace?
I think we could probably both answer that. Certainly one of the things that we've been looking at is ways to reuse existing PPE, whether it's with various ways of sterilization. There are a lot of challenges with sterilization. If a clinician is using PPE and it gets contaminated, how do you transfer it to a place where it can be safely decontaminated without infecting anyone else? So there's a lot of logistics to that as well. But certainly we've been looking at reusable PPE. Landon can talk about how some of his capper cuffs and so forth are disinfected. But yes, absolutely, that's something that we've been considering.
Yeah, that's right. So the capper cuffs specifically, so these are, they're disposable items, but at the same time, we've designed them to be reused as much as possible. Typically, they break down mechanically from being removed and put back on the helmet eventually, but they are taken off, and the material that we've chosen can be wiped down and sterilized. Also, the innovation shields, for example, that was one of the decisions that we made, and trying to decide what material make that out of, right? So we made it out of a material that can be sterilized and even autoclaved. So yeah, absolutely. There was definitely, that was part of the design process was using materials that could be reused.
Very good. And so the final question that we have in the Q&A, how is the university approaching and promoting summer internships with the risk of exposure to the students?
So let me share what we're doing on that. Well, first of all, some of these summer internships that were all planned to be in person, some of the companies have actually shifted them to remote internships, right? So in those cases, those fortunately are continuing. And then the ones that are still in person, the university has worked out a protocol that's based on assuring, the safety and health of the students in that, but that protocol is worked out together with the host company. For example, Duke Energy has a number of summer internships for our engineering students. It turns out that Duke Energy has a very strict protocol. It's really to support the safety and health of their own staff and their own employees. So any of our students that are involved in that operation would be subject to that. And that also works within the protocol that the university has established. But the reality is that we're having to work those out almost case by case. And some in-person summer internships have just simply been canceled, right? Because there hasn't been a way to work out the protocol. And in other cases, some of the companies themselves have actually canceled the internships, but for other reasons, right? For reasons of their own financial situation or whatever. So those that can be shifted remotely have been shifted remotely. Those that are in person have been worked out case by case. And, with some of them simply not being able to be carried out.
I'd like to add to that if I could. All those things are true. And because we knew that there would be students who had planned internships and who were not able to, departments across the university ramped up the summer classes. So we have a larger number of students in class this summer, both because of summer internships and postponed study abroad.
Yeah, that's a really good point that Julie's making. In fact, in our case in the college, to go the summer online was probably less difficult than even in the spring. We do have quite a few online offerings already in the summer. All of our master's degree programs are offered online, for example, and some of those courses are also available for undergraduates. But that's a really important point, offering alternatives to those students who are not able to do summer internships. And so a lot of it is to try to complete, that demand one way or the other. Yeah, thanks, Julie. Thanks for bringing that in. Yeah.
Okay. And we've got a couple more questions that have come in. Do you think that new ventilation, filtering, and outside air percentage standards will be coming out from ASHRAE as a result of this pandemic? Great question. Who best to field that one?
We needed John Royal on the panel, our facilities guy. But Landon, Dayton, Julie, you're pretty familiar with some of that too. Why don't you guys go ahead?
Dr. Dayton, if you have comments, you're probably closer to it. Yeah, there we go. Dr. Dayton.
Oh, no, I was going to say, go ahead. There would be some benefit to increasing filtration performance and things like having less recirculated air, but I don't really know what facilities is able to do and what they're working on. So I can't really answer that question.
Okay, I'll take the other half of it, which in general, what the epidemiology and public health has shown is that HVAC systems do have a role in disease transmission sometimes, and there are some systems that are better than others. And I think that the more that science continues to come out, then it is possible that we would see some of that reflected in standards changing. But I don't know what kind of timeline that might occur or how certain it might be.
Yeah, let me just add that this is a big challenge for us at the university because the variation in what the situation is building to building is really, really pretty broad. I mean, we're talking at some buildings that are relatively new and others that have been around for 60 some years or whatever, right? So I know that our facilities folks are really having to get into this with a lot of detail, but one would hope that that would be part of what could come out of this, right? Is something that would be a standard that would sort of take more of this in mind.
Good. Thank you. For sure, areas of research to come. All right, couple more questions. Thank you for the amazing things, panelists, that you are doing. Did you get any financial help from big health insurance companies?
I will say that everything that BME has done so far has been on our own dime because of the urgency. And later we'll go and see if we can get some assistance.
I think Paul's right. I mean, I think, this is kind of preempting a little pitch at the end of this presentation that I'm going to make, but we do need more help and support. Anyway, let me just leave it at that. But has anybody, Julie, have you or Landon, have you guys gotten any? Because I know that there's one thing that hasn't been mentioned. BTech, our biotechnology manufacturing and training center, is also playing a major role in trying to help support some of these efforts, in particular the production of sanitizer. And in that case, they've been able to move this production forward because of a really very significant donation from Novozymes that had to do with ethanol that has really gotten their production in shape. So I don't want to give the impression that were not getting support, right, from the private sector. But the question was specifically large health organizations, and I'm not sure if we can document that specifically, right?
No, we do have, yeah, we do have partnerships, and they have partnered with us on going after federal agency funding that is specific to COVID-19, but we have not gotten the kind of funding that was specifically mentioned.
Right, right.
Yeah, no financial help to me. I'll take it though. We have interacted with specifically Blue Cross Blue Shield of North Carolina was involved in some of the coordination of face shields early on.
All right, we've got a couple more questions, see if we can get to them. Given that there is lots of technology that was developed in the past that can present financial challenges to the status quo, for example, Tesla global distribution of energy and Royal Rife treatment of diseases, how would such technologies be able to move back to the front of our research efforts? That's a deep one.
Yeah, well, let me try a bit on that. I mean, I think it's pretty clear that we have this immediate challenge, and so a lot of the focus pivots to this, right? It has to pivot to this. Like Paul talked about in the BME department, it's not like they don't have a lot of things going on and a lot of research going on, but in addition to that, Paul, you had to pivot into this domain with your faculty and students. Julie, you had to do the same thing. It doesn't mean that we're stopping to try to do the other things that we have been doing, right? But the reality is that we now have a lot more things on the plate. I would think that those things that somehow could be concurrent in some way, that both help address the immediate needs and also have these other long-term implications in other areas, will be some of the things that will continue more easily. But it isn't like our faculty have stopped doing the other things that they're doing. You know, our people are writing their proposals, they're doing their grants. There's a lot of anxiety, you know, obviously to get back into the labs and do the work that they've been doing in the past. And a lot of it is to try to do this in a measured way with enough patience, right, to assure that it is done safely and, you know, we can keep, you know, moving this particular needle forward in a positive way. I know it's a very general answer, but I think that's the best I can share at this moment. Yeah.
Thank you, Dean Louis. And at this time, we want to be respectful of people's time. So there are some unanswered questions, and we will get back to you. Everyone will, through written answers, and folks that have signed up will get a copy of this video of this event. And so with that, Dean Louis, can you close us out?
Yeah, I just thank you, Pam. First of all, I want to thank Pam, and I want to thank all the panelists and everybody who's on this call and all the chats. And, you know, we're really delighted that we could do this, but at the same time, we're very motivated by your interest and your response. Fortunately, the university, given all of that's happening, is in fairly good shape for this fiscal year, but we all do not have any idea really about what's going to happen in the next fiscal year. The state budgets, many of you, I'm sure, in your companies and industries, you know, there's a tremendous amount of uncertainty with that. So that's going to mean a lot of challenges going forward. But I think my closing message is really focused on the following. I'm going to come back to Leah and everything that she shared with you. And Leah, I thought you just gave a wonderful, you know, overview of the things that you've had to deal with. Our students are phenomenal. They are resilient, and they are the reason why we are here. And I'm going to ask you to please keep supporting our students. And what do I mean by that? You know, as I mentioned, some of these summer internships are not happening, but partly it's because the companies can't make them happen. We have students that have job offers that have been rescinded. We have students that have job offers that have been delayed. People's uncertainty about what their futures may be. Our job has been to make sure that they have completed their requirements, their degree requirements, and can move forward. I'm asking you to make sure as much as you can in the domains that you are to help them move forward. Keep the internship opportunities there if you can. Keep the job opportunities there if you can. I remember in the last recession, our career fair went down from 270 some companies that came in to about 180. But those that kept coming in, even when they didn't have jobs they could offer, still provided internships and still maintained the relationship with our students and our college. And that's what I urge you to do, because this is going to turn around, this is going to change, and at some moment, those who maintain those relationships are ultimately the biggest beneficiaries, not just our students, but you and your organizations in terms of your future. That's really critical for us. Focus on anything that you can do to help our students. I know a lot of people have been very responsive, from the donation side to the Student Emergency Fund. Over $1 million have come in from alumni to help support students and student needs. And I think, Pam, 600,000 to 700,000 of that has been dispersed. But even there, you know, that's something that still has continuous demand. From a company perspective, what Novozymes has done, if you have ways that you can interact with our faculty on their projects and provide them support and materials, all of that I think is going to be very, very critical. We're committed to continuing to do everything that we do the best way that we can. And again, you know, I can't be prouder of how everybody in our college and this university has responded. But at the same time, the alumni support that we have, the fact that you're on this call and you're concerned, is something that also means a great deal to us. Ironically, I received some data yesterday that really shows that in many cases, alumni contacts and interest has increased in this period. I think between March 15th and May 15th of this year, the number of alumni contacts and responses has almost doubled from last year in very targeted ways, and we very much appreciate that. But do understand that we're all going to need the support and have to work together even more. There's a lot of uncertainty about how we're going to carry this through in the next year and possibly the next couple of years. You know, we're all on this together. You know, this is a tremendous Wolfpack community. And that's really my message to you. Stay close to us. You know, work us on terms of the kinds of the things that you think that we may need. Just tweet us on these things and stay in communication. And, you know, we look forward to doing everything we can do to assure that our students are able to continue to move forward with their careers, and our faculty with the tremendous things that they're doing on behalf of our society. So Pam, let me just close it at that. And if we can do all of that, I think we're going to come out even stronger on the other side. And that's about it. Yeah.
Well, thank you all so much for joining, and hopefully you gleaned a good bit. I know I have from these talks. So go Pack and have a wonderful Memorial Day weekend. Take care.
Absolutely. Thank you, Pam.